Hello students, here's a demonstration of uniform circular motion. Now this over here is the radius of the circular motion and that's a nice cute spongy smiley ball. Let's see how this goes. You can see that it's changing direction at every point on its orbit. However, the speed is remaining constant. How do I know about the direction? Just watch what happens when I suddenly decide to leave the ball. There you go. Now let's try one more time. This time I'm going to leave it at some other point in its orbit. So here goes. Now I'm going to leave it. Once again, here goes another trial. Now I'm going to leave it at some other point. So the point is, at every point of its orbit, this body will have a different direction of motion. Since the direction is changing, even though the speed remains constant, we say that this is an accelerated motion because acceleration is a vector quantity. Acceleration has magnitude as well as direction. Here the magnitude is not changing, but the direction is, as you saw just now. Hence, uniform circular motion is accelerated motion. So coming back now to the concept of uniform circular motion inside the class. Well, it was fun for me showing you the activity outside. Let's have a quick revision. Scalar quantities versus vector quantities. Scalar quantities like speed and distance have only magnitude. Vector quantities on the other hand have magnitude as well as direction. Velocity is one such quantity. Velocity has a direction as well as magnitude. If you take this direction as positive, then this direction becomes negative. Similarly, when we talk about acceleration, which is defined as the rate of change of velocity, let's ask ourselves, how do we change velocity? We have three ways to change the velocity. Either I change my speed, or I change my direction, or I change both. Now let's talk about uniform circular motion in this context. When I'm taking something around and around, even though I am able to maintain a constant speed, am I changing my direction? Of course, at every point it's along the tangent. So because there is a change in direction, automatically the velocity changes. And because velocity changes, there is an acceleration, no matter how difficult it feels, because acceleration is defined as the rate of change of velocity. So ask yourself, every time there is a change in velocity, there has to be an acceleration. An athlete running on a circular track. There are so many numerous examples that we can relate. How about the planets revolving around the sun, the moon going around the earth? Wonderful examples of uniform circular motion. How about the wheels of a car? Each and every part of this motion is accelerated motion. And this is what we really need to understand very well, that even though the speed remains constant, uniform circular motion is accelerated motion.